I'm going to add another case that might happen in permutations. So this time we've got our n objects. We're going to arrange them, but not all of them are different. In other words, some of these objects, when we look at them visually, they're the same. They're the same thing. Let's build it up and see if we can't get a pattern. If we're talking about just two objects, now if they're all different, so A and B, we've got A and B, B and A, and we worked out that, oh yeah, that's 2 factorial, two ways of doing it. But what happens if they're the same? Well, now there's only one way, because if I swap them round, well, visually it's still the same thing. So there's now only one way of arranging them. Okay. How do I get from 2 to 1? Well, maybe I subtract 1, maybe I divide. Let's have a look at 3, see if we can't pick up a pattern. If there was 3 objects and they're all different, there they all are. We know 3 factorial is 6. What happens if we make 2 of these the same? So now I've got 2 A's and a B. And all of a sudden it narrows it down to 3. So it looks like I can't just subtract 1. But I could maybe divide by 2. Maybe that's what's happening here. 3 the same, oh, we're back to 1. Oh, how did I go from 3 to 1? Obviously I haven't divided by 2 this time, but I've subtracted 2. Well, maybe I've divided by 3. Let's look at 4 objects then, see if we can't pick up this pattern. Alright, well, if we have 4, there's 24 different ones there. 2 the same, 24 to 12. Ah, there's that divide by 2 again. Well, what happens when 3 are the same? 3 are the same, 4. How do I go from 12 to 4? Divide by 3. 3 the same, righto. All 4 obviously is now 1. How do I go from 4 to 1? Divide by 4. So this is the pattern then. If we have n objects, we're going to arrange n of them, but x of them appear to be the same. It becomes this. N factorial over x factorial, because what we're doing is we're saying, well, hey, if they're all different, we know it's going to be n factorial. But some of these are the same. So we divide by the number of ways those objects could have been arranged if they were different. So there are x objects that were the same. Well, there would have been x factorial ways of arranging those objects. But now the order doesn't matter because they're all the same. Visually, no matter which way we put them, we're going to see the same thing. So we divide by that. How many words can be formed using all the letters in the word Connaughton? Connaughton has 11 letters, but we have 2 O's. We also have 3 N's. So we divide by 2 factorial and also 3 factorial, and we end up with, there we are, find them. No, we won't ask that question. Whoa, imagine that. Here's an HSC one. In the HSC, they tend to assume nothing. The letters A, E, I, O, and U are vowels. How many arrangements of the letters in the word algebraic are possible? There are 9 letters in the word algebraic, so 9 factorial. We have 2 A's, divided by 2 factorial. Well, how many are possible if the vowels have to occupy the 2nd, the 3rd, the 5th, and the 8th positions? So look after those conditions first. Well, let's place the vowels. There are 4 of them. 2 of them are the same. So 4 factorial and 2 factorial. Right, they're in their spot. Now go arrange the other letters. There are 5 other letters, 5 factorial. And we get our answer, 1440. Okay, shall do us, 14D.